So these are first instruction. Okay. First one is execution. What is stack pointer value? Stack pointer 16-bit register. What is stack pointer value? Tell me. E358. What is stack pointer value? E358. 1000 starting. Okay. So 1000 starting. What is instruction size now? What is size of the instruction? What is instruction size now? LXI. 3 byte. 3 byte now. 1000, 1001, 1002. Next instruction start. Next instruction start what? 1003. Next one start from 1003. Yes or no? 1003 start also. 1003, 1004, tell me 1005. Next start, tell me 1006. What instruction size? Push B. 1 byte. 1 byte. Because operand contain what? Register. Register pair only. Okay, no. Tell me 1000 what? 7. What instruction size? 3 byte. 1007, 8, 9. 1000 what? A. 1000 what? Tell me. A. Aggressment number now? Not 1000 what? A. Aggressment. Okay. So now you can see what a push and pop only. First one is execution stack pointer value E358. What a BC value? Tell me. Hello. What a BC value? Tell me everyone. 1, 2, 3, 4. What a push now? Push your study now. What a push instruction? Stack. Is there some area in the memory? Okay. No, that's some area. The memory also some area is there now. The whole thing is memory. 4 zeros to 4 Fs now. But this area is called what? Tell me. Temporary memory. Some area, some zone in the memory. Some area. They call what? Temporary memory. The shortcut is a stack. What kind of call it? Stack. Is also called what? No. Stack. Temporary memory. Understood now. And people observe now. This area. Okay. This area we are called a program. Tell me. Code. Code area. Code area. Program area. Code area. Program area. People, I told now the difference between Harvard architecture and Hanuman architecture. So program memory separate, data memory separate. Program memory only program only. Data memory only for what? Data. Understood now? So data like that. Temporary memory. The temporary memory, the purpose it can store temporary some data. Temporary data. Store data. Now your C programming language, everyone is pronounced like a local variable. Which one? Local variable. Tomorrow write the C programming language, no? Local variables, no? They have any function, no? Local variables are there, local. Understood, no? The function, the beginning, function what tell me? Ending. Here some local variable, some variable, no? Integer x equal to 5 is a local. The meaning of local variable, the scope of the variable, function cannot visible. Okay, I told yesterday also, very simple understanding. So my context is a right now explain the class only. The main context, the main function. Whenever I want move my main function to another function, like a phone call conversion only. In the phone call conversion, I can use some data. The data is not visible to here. Yes or no? In the phone call, whatever I'm discussing, that context, that not coming to what? Here. Yes or no? So that is a local variable. What is a local variable? There are two different contexts now. So every function is one context now. Okay, that context not understand the another context only. So right now my brain is what? Classroom. Explain the class subject. The my context right now. Once if immediately I can stop the class, I can go to phone call conversion. Total different or not? That context variables are what? Different. So the local variable we are going to store, where you can store, tell me, stack. Where you can store stack. This is a which area? Tell me, code. So your RAM divide into different areas now. Code area only program only. Local variable stack only. Global variable data area only. Heap area like some divide into some particular what now areas in the memory one. Okay, divide into. So why a temporary area separate one? Why divide? You see understood. Okay. What is reason? See clear. So this temporary area, you want to store some temporary data here. Okay. The temporary, the meaning of temporary, if definitely I want to come to the main context or not. So my class is the main context, no? So that is only for what? Tell me, temporary. If definitely I want to come back or not, no? So the temporarily we can put some data, you can implement, you can do some calculation, you can implement. Whenever you want to come back to the again the another context, you remove the data. We don't need requirement now. The data not required because that is a gone. Okay, here we don't discuss about at all. The whatever the phone call conversion, everything never appear in the here. Never, understood? Appeared. Okay, so that is the reason of the context. That is why you are separate context creating one. Yeah, not visible. Okay, so now you can see here, but the temporary area, stack area, but this the code area. The code area is a only code, only for XX, only for your what I mean, only for tell me your mnemonic, what exa code, only for exa code. One is 78. So no, what exa code, only binary code is there on a code area. Here no variable actually, there no like a data. Data is coming to what tell me here. Data coming what here, a perfect no area no data. No. Only for what code. So code identification, code point out na, the code is a separate area, is some address now. Is some address or not? Hello. Code where can code starting tell me? 1000. This program where can start tell me? 1000. 1000 is there onward, the code area not no. The code point outing, microprocessor point of view, the microprocessor to communicate the memory, load the instruction, the code area, the address, where you can load? Where you can load tell me? Program counter. Program counter hold the address of the next instruction. Address of the next. Program counter keep on incrementing. Okay, the program run line by line na? First line. Next what? Second line. Understood? Program counter. Similarly, we have one more is there. Okay, this is the right time to discussing about stack pointer. Understood now? Similar one more, which one is there now? Stack pointer. Program counter hold the address of the program area. Address of the what? Program. Okay, that is no, we are moving instruction some address only. Stack pointer hold the address of what? Address of what? Temporary memory. The data. Temporary memory what? Tell me. Data. Understand everyone now? My point. Stack pointer hold the top of the stack. The stack pointer hold the what? Top of the stack. The stack no. Stack nothing but temporary, the meaning. Okay. Program counter hold the address of the next instruction. Okay. Address program area, program counter, stack pointer the stack area. Okay. So now how push instruction works so now? You see the very important action now. Okay. Now the push RP, very important action. Push RP. Okay. Now you see push is a register pair action now. Register pair now. Push register pair. Push RP, register pair. Okay. Push RP. So the meaning of push instruction, the meaning of push what? The meaning of push transfer the data to the memory location. Push. Okay, it's the same like a store like that. You know, store na? The meaning of store what? Data transfer from processor to what? Memory. The push also same thing only. The meaning of push, the information transfer to where now? Memory. Yeah. But memory temporary memory. Which one? Temporary. Push is a instruction, data transfer to the stack only. Where you can transfer? Stack. Push. Okay, your STA. Okay, the STA or X, the RP. Push RP. What difference now? The push RP, the data transfer to where? Top of the stack area. STX RP transfer to the memory location. Not a stack only, normal memory. Not a stack only. Stack is what the purpose tell me? Temporary. What tell me? Temporary. For example, program beginning time, I create one data. But the data should be global. The end of the program, the data should be available. Then you can go to the global. Global, you can go this one. Global. Global, end of the program is available. Global. Always the variable should be there. The data should be there. Push what? What a push tell me? What a push tell me? Temporary. Local variables. The C programming language, we have two things. Local variable and global variable. Local variable, you can go to the what? Push, stack. Global variable can tell me. ST, X only. The two things are there. Yeah, just a minute. Okay. How the push instruction whenever executed now? So the content of the register pair, where you can copy tell me? Top of the stack, the main definition. Okay. Copy top of the stack. Okay. So now how it works, you can see now. The register pair content, okay. Register pair nothing but, you know, the meaning of register pair, higher address and what? Lower address. Correct, everyone? in case BC pair is there, the B, that is about what? B and what? C. Okay. Higher address and lower address. You can transfer byte by byte only. Correct? First you can transfer register higher address. Okay. Where you can transfer stack pointer. Where you can transfer stack. Stack pointer to who? Stack pointer not no. Stack pointer then correct? Yes or no? So stack pointer decrement by one time and you can transfer on. Why decrement by one time? Because previously what happened, tell me, your LHLD, SHLD, we are increment the one location. First to copy L, next increment the number location, copy the what? H. Observe everyone. Previously, every time you are going to communicate the memory, now what you can do? Incrementing and copy. But stack is what, tell me? Decrementing. Why decrementing nothing but stack is always, people observe no, end of the memory. End of the, you can see observe no, end of the memory and almost now. Hello?
Yes.
Everyone observe not no. Stack is always where, tell me, end of the memory. Why end of the memory? Temporary. Why tell me? Temporary, no, there is reason. Temporary, remember, no, not a permanent memory. Temporary. Understood, no? Temporary memory, end is always better no. Okay? You create some amount of data, after some time, delete now. Again create, delete now. Again create, delete now. What kind of information? Tell me. Temporary. Okay? No, understood everyone no? Yes or no? A temporary memory no. Okay, information. That is the reason we are decrementing actually. Whenever you can start end of the memory nothing but end last location onward start nothing but you want copy what? Decrementing and copy. Decrementing and copy. If you're starting from the beginning onwards, what? Incrementing and copy. Yes or no? Stack is starting from, tell me, end. You know, no? That's why not stack pointer what? Decrement by one time. Stack follow LIFO principle. Last in, first out. Last in what? First out. LIFO principle now. See, LIFO. Last in, first out. How you can see? The first step now. Stack point first step. Second step, lower address of the register. Where you can copy? Hello. Where you can copy? Stack pointer one more time. Decrementing. Stack pointer one more time what? Decrementing. Push instruction execution. The two steps are there only. Push definition only. Push. Push RP. Push RP now. Push RP. Okay. Before push. Tell me. After push. Program counter, stack pointer. Program counter, stack pointer. After push only. So everyone listen careful, okay? No, just 2 minutes. Listen. Before push, you can see. First starting no, PC values. Everyone listen carefully. Very important actually. First program counter value is 1000. Yes or no? Your program beginning here na? Yes, program start here. What first PC value what? 1000. Whenever the first instruction execution completed, SP value what? Tell me. E358. SP value E358. Whenever one instruction execution completed, program counter point out the next instruction address. Next instruction? What next one address? Tell me. 1003. That's why your C program run line by line only. First one over, next what? Second one. Next one, second one. Line by line running or not? The job done by what? Program counter. The program counter incrementing the next memory location depending on the size of the instruction. Depending on the what is instruction size now? 3 bytes. PC value what? 1003. What is instruction size? 3 bytes. PC value what? 1006. What is instruction size? 1 byte. PC value?
1 byte. 1007.
Understand everyone? First PC value 1000. This instruction over PC value 1003. Like that run by run also. You understand now? Now PC value what happened? Tell me here. 1006. Before push now. Before push. What before the push not execution? Just now program counter point out on it. Just now. What value? What value will tell me? 1000. Hello. 1000 what? 6. Before push now. The push not run, just now program counter load the what? 1006. Yeah, 1006 now, around, yeah, 1006 now. Here program counter the point out also. Just the program count identified now. Just hold. Before push, PC value 1006. Stack pointer value. What is stack pointer value? Tell me, hello. What is stack pointer value? E358. First instruction only, SP value E358 only. Wherever you can know the push and pop, stack related instruction, call or jump, wherever you can know the push and pop under stack related instruction, before this instruction, programmer responsibility to do this activity. This one is called a stack pointer initialization. Stack pointer initialization. Programmer responsibility now. First starting line of the program now, every program beginning is a stack pointer initialization. Where the C program is main function. The back end, the first two line of the instruction is a stack pointer what? Initialization. Compulsory now. Stack pointer initialization. The stack pointer initialization to tell me end of the what? Memory. End of the what? Memory. Where the push is there, the compulsory now. Understood now? Is stack pointer not initialization? We point out the something middle of the memory or beginning of the memory. It disturb the program or not? No? That's why stack is always what? End of the memory now. The compulsory you want to know. Okay, next one. Yeah. Stack pointer value here E358. E358, correct now. Before push only. Now after push nothing but push instruction two steps now. Hello, push instruction what? Tell me. 2 steps now. Okay. Yeah, 2 steps only. What first step? Tell me. Hello. What is first step? Stack pointer decrement by 1 time. You can see stack pointer value E358 now. Stack pointer value, tell me, E358 decrement by 1 time. Tell me, hello, E357. E357. There copy which value? Okay, correct now, everyone. E357. Here copy the which value? Which value? Higher. Which is the higher? Tell me, BC pair now. BC pair higher. What? Tell me, B. What a B value? Tell me, hello, 12H. Yes or no? Hello. Yes or no? What is second step? Stack pointer value again decrement by the one more time is 2 times overall.
Times C value.
56. Where you can transfer now? H. What a value? Tell me.
34H.
34H.
Hello, correct? So the 2 steps run also. Whenever the 2 steps are completed, so whenever push backend, 2 instructions are there only. The 2 instructions are what? First instruction, data transfer from processor to memory. Second instruction, tell me processor to what? Memory. First one is there, tell me processor to memory. First one what? Write cycle. Second one also tell me write cycle.
Right.
You understand that now? The push instruction, now 1 fetch cycle plus tell me 2 write cycle. How many? 2. So because no, what to me? Processor to memory. Processor to memory. LHL delay, SHL like that don't know. Understand no? Clear or? But the push instruction, what are the content of stack pointer? The blindly, whenever push no, that moment, whatever stack pointer, that moment. Okay, the definition like that. That moment, what is stack pointer? No, that value decrement by 1 time and copy the B register. And again, one more time decrementing, copy the what? C register. Now, top of the stack, end of the memory, last memory, your temporary data you can store now. What temporary data? Tell me, what temporary data? 1, 2, 3, 4. Temporary data can store also. The push instruction execution over on now. So after push over, what are the push instruction size now? What are push instruction size? 1 byte. Push is over. Next PC value what? Hello. After push, next PC value what? Tell me 1007. Okay. After push instruction, stack pointer before the push stack pointer what? E358. After push now 3 steps now. What stack pointer value? Hello. What stack pointer value? E356. So every push instruction stack point rate decremented by 2 times. Standard definition now. Okay. So every push instruction stack pointer is decremented by 2 times. Stack pointer is decremented by 2 times. Every push instruction stack pointer is decremented by 2 times only. So before push, after push on clear. So after push is over, now top of the stack temporary data is there. Okay, 1, 2, 3, 4 only. So every push instruction stack point decremented by 2 times only. So now people observe now the very, very important point. One more here. See clear. So can I see the BC register now? So 34 watt lower byte. 34 watt lower byte. Lower byte store the lower address. Hello. Yes or no? Higher byte store the which address? Higher address. Lower byte store the lower address. Higher byte store the higher address. Which architecture? Hello, which architecture? Little Indian. Which architecture?
Little Indian.
People observe no LHLD, SHLD. LHLD, SHLD first to transfer the lower byte. First transfer the because no, the LHL, SHL what? Incrementing and copy. Yes or no? Push what tell me? Decrementing. That's why we can transfer the first two. First you can transfer the what tell me? Higher byte. First transfer what? Higher byte. The people understood or not? No need by heart, no. Nothing. No need by heart. Concept only. Understood or no? The concept simple. Okay, no, what a push and pop tell me? Decrementing. No, LHL, SHL, STL, what tell me? Incrementing. The only here, the people are mainly confusing here. Mainly is the push and pop is the decrementing because it's the end of the what? Memory. The decrementing and copying, not incrementing one. We can start from the last location onwards now. We are copy, decrementing one. The concept understanding is simple. But finally, your requirement fulfill now. What a final requirement tell me? What a final requirement now? It in Indian. Everyone observe not now. Push B. The meaning of push B, people observe now. C register content 34. We can transfer the what? Lower byte. Yes or no? C is a lower byte. B is what tell me? Higher byte. Transfer to where tell me? 1, 2. So now higher address. Lower byte transfer the lower address. Higher byte transfer the. Understood now? This is important. Yeah. Tell me any question? So push understanding. I'm telling you, your people understand the push only. Pop is what? What a pop? Reverse. Push something but copy the temporary data top of the stack. Pop is what? Retrieving. Pop is what? Tell me. Retrieving. Data transfer from top of the stack to memory to what? Processor. Memory to what? Processor. Understand everyone? Hello?
Yes, understanding.
Yeah, tell me.
Sir, here we are decrementing SP by 2 times.
2 times, sir.
Sir, I want to say since we are using here 2 bytes, so we are decrementing it 2 times. If we are using 1 byte only, then at that time SP will be decremented by 1 only, na? Like we are storing 1, 2, 3, 4 in BC. Suppose we are using just 1 byte of information. Then at that point, SP has to be decremented just by 1.
No. Push instruction always transfer the 2 byte of information. It cannot transfer the 1 byte of information. It transfer the compulsory 2 byte of information. Other byte you don't want transfer, put a dummy data, no problem. But it can transfer how many bytes? Tell me. 2. Push instruction. There is no instruction transfer the 1 byte into the top of the stack. No instruction. Okay. Clear on the push register pair. Okay. The register pair, no 16-bit data. Okay. The register pair what? 16-bit data. 16-bit data transfer to the top of the stack only. BC content. What is BC content? Transfer to the top of the stack only. Push. So you can see next pop is there. Second instruction. Next instruction, the BC content overwrite now. BC content what? Overwrite. But overwrite, but don't worry on. But previous value you can copy the top of the stack or not. Understood? No. That's why the local variable purpose action. We can store some data in the top of the stack. After some time, we have some calculations are there. After some time, the water data we store back now, that we need again. The data what we need what? Again, call back now, retrieve now again. So that's why now we can go which one tell which instruction. Hello, which instruction tell me? Pop.
Pop operation.
Pop. Pop is reverse operation. Whenever pop is successfully executed, what is top of the stack now? Exactly where you can store. Where you can store, tell me. D. Reverse now. So tell me pop reverse now. Pop register pair. See what a pop definition. the first step of the pop, what are the content of the top of the stack? The stack pointer, no, that movement. What are the content of the stack pointer, no? The content transfer to, tell me, transfer to what? Register lower. Stack pointer now incremented by one time. Transfer to where, tell me, register what? Higher. One more step, stack pointer, one more time incrementing the previous the value. You can store the again stack pointer one now. Okay, not a braces only. Stack pointer value, one more time incrementing, store stack. The 3 steps are there now. How pop instruction works? 3 steps are there now. 3 steps now. 3 steps now. You can see the before pop, after pop. Before push, after push over now. Next. Before pop, after pop only. Note down. Before pop, after pop only. The before pop is a 100 A na before pop. Program counter value. Okay. Before pop. Okay. So what are step by step now? What first step, tell me? Pop. Pop D.
It will get the lower bit of SP.
Yeah. So what a pop D first step now? First step is the what? Tell me the step now. Stack pointer. So
Right.
pop is a before pop, no? Before pop, PC value what? 1000 A. Before pop, just the program counter point out. Before pop, what SP value? Hello. This moment, what SP value?
356.
SP stack pointer value.
E356.
Stack pointer value, what? Tell me. What? E356. Whatever. E3 what?
56.
E3 what? 56.
The last value.
Correct? No. Last value, recent value E3, 56. Before pop one now. So now can see first step now. What first step? Tell me. What first step? The stack pointer value. Tell me. E3, 56. So, E3, 56 now.
Will be
E3,
stored
56.
in. Yeah.
E3, 56. What are the content? Where you can transfer? Yeah. Register pair. Higher byte or lower? Lower.
Lower byte.
Lower nothing but what? DE. Which register? E register. Register. Next one. Okay. Next one what? E3, 57.
7.
Where you can store? Tell me. D.
D.
Okay. Next third one. What third one? Stack pointer. No,
That's true.
56 plus 2 na. What? 5, 8. Where you can store? Where you can store? Stack pointer.
Stack point.
Stack pointer. 3 steps are done only. 3. The 3 are completed. The 3 are completed. So, DE content no push D na. The push D. Pop D. DE content what? Hello. The 3 no. After pop no. What DE content? What DE content?
56 and 57.
DE content no. DE content is a what? Tell me.
D.
3, 4.
Yeah.
3,
Huh?
4.
DE
1,
content
2,
I'm asking about. Pop D no. Pop D successful. What is DE content? Hello. After
1, 2,
pop,
3, 4.
what DE content?
3/4 whole. Correct.
E3, 5, 6 content what? Tell me. 34. 34 where you can store? Hello. 34 where you can store? E. E3, 5, 7 what content? 12. 12 where you can store? Tell me. D. Okay. Understood or not? D na?
Yes, sir.
Yes or no? Understood no? D content what? 1, 2, 3, 4. The meaning of pop D, top of the stack content, where you can store? Where you can store? Tell me. D. Where you can store?
D.
D. So after pop, what a pop instruction size now? What a pop instruction size? 1 byte.
1
What pop instruction size? 1 byte. So now after pop no. So next 100 B na. Before
Yeah.
pop is what? 100 what? A. After pop execution, PC value what? 100 B. What is stack pointer value? What is stack pointer value? Tell me.
358.
58. Last value. 58.
E3, tell me 5, 8. Last one. No? E3 what? 5, 8.
58.
So what happened? Every pop instruction, check it now, everyone. No? Every pop instruction, no? Check it now. So every pop instruction, tell me. Every pop instruction, okay? Every pop instruction, stack pointer is Tell me. Incremented by how many times? Hello. Time.
+2.
Pop instruction stack point incremented by 2 times.
2 times.
Push instruction decremented by 2 times.
Decreased by 2 times.
So previously I told before push, after push. Now I told what? Before pop, after pop. So here some points now. The programmer responsibility, compulsory program beginning time. What happened? Stack pointer initialization.
Should be initialized.
And one more responsibility, in your program, how many number of push instructions you are using? That number of pop instruction mandatory. Yes or no? So 2 push are there, 2 pop. And so then only stack pointer perfect. Ultimate solution is a program beginning time, what is stack pointer value? The same value should be there end of the program. Same value should be there what? End of the program. Understand? No? Stack pointer what? Decrementing and copying. Again you want to tell me, retrieve the data. What happened? Incrementing. So temporary data you can copy, decrementing. And after tell me what? Retrieve. Again go to what now? Top of the stack point. Understood? No? So stack is a one temporary memory. Okay. So I can go to my phone call conversation. There have some data is there. That data temporary, that moment only. Once I can come back, no, gone. If again I can go to that conversation, I remember, recall. Understood, everyone? So there is another way to write the code action. Understood? So there's a push and pop is a very important action now. So push and pop also data transfer instruction. Data transfer instruction. Okay, push data transfer from, tell me, processor to memory.
Memory.
Pop data transfer from
Process.
memory to processor. Okay. So the all are the data transfer instruction. Okay.